For thousands of years, an annual migration has been taking place in the North Atlantic. After feeding for over a year in the food-rich northern waters between Iceland and Norway, these Atlantic salmon are now coming back to the river of their birth, on the very north coast of Ireland in County Antrim, the River Bush. The peat-stained water, with its own distinctive smell, is used by the salmon in identifying their river as they come back with one mission in mind: to head far upstream, find a mate, and spawn. Salmon numbers across the globe have been falling steadily in recent decades. The River Bush Salmon Station was established in 1973 and is only one of a handful of salmon monitoring stations across the Atlantic Basin. It is internationally important for salmon management and research, with its long-term salmon monitoring programs. The Bush is an international council for exploration of the Sea Index Salmon River, and the basis of the Northern Ireland Salmon Management Strategy. The salmon station is built on the site of an old water-powered corn mill. The weir acts as a barrier to prevent fish moving upstream, and all migrating fish are diverted to run in a channel of fast-flowing water into a fish trap where they can be monitored in terms of numbers, weight, length, and general health. The floor of the trap can be raised mechanically, thereby lowering the water level and exposing the fish. The salmon are netted and placed in an anaesthetic. The fish are examined quickly and carefully, and data such as sex, weight and length are recorded. Any farm salmon escapes or exotic visitors such as pink salmon are noted and removed from the river. Scale and DNA samples are also taken from some specimens. The general health of the returning fish is monitored and predator damage and sea lice numbers recorded. A few salmon may be tagged with acoustic transmitters to track their journey upstream to the spawning beds. The information collected at the trap not only indicates numbers of returning fish, but also assists in the numerous other scientific investigations, such as the trend which is appearing of increasingly smaller and leaner returning salmon, and the theory that it is caused by a reduction in the quality of feeding at sea. There is also a salmon hatchery on the site. It produces 60,000 hatchery-reared smolts per year to monitor marine survival of discrete age groups. The The hatchery salmon are identified by their trim adipose fins. Many are also tagged with a microscopic coated wire tag inserted into the nose. These fish can then be identified should they return to the river or should they be recaptured on the high seas. A sensitive metal detector can identify the presence of a tag. The wild salmon, once measured and recorded, are quickly returned to the river upstream of the farm. The hatchery fish, however, are retained for broodstock and are kept in huge tanks which have a water depth of over 1.5 metres with a constant flow of river water. They are sorted into male and female and are cared for until spawning time. In the river, the wild salmon head further upstream in search of their spawning grounds. The fishing season is now long over. The leaves have fallen from the trees and the weather is cold. As the temperature drops and the frosts appear, in the spawning areas, the salmon pair up and start to dig depressions in the gravel called redds, in which to lay their eggs. And finally in December, when the conditions are just right, spawning occurs. Back in the salmon station, the broodstock have ripened with eggs and sperm. They are now ready for stripping. The water levels in the holding tanks are lowered and the fish are anaesthetised to make it easier for the fishery staff to handle the fish, and it is better for their welfare. They are brought into the hatchery and the ova from the female and the milk from the males are stripped by gently applying pressure on the flanks of the salmon. They are mixed in a basin where fertilisation takes place. This process takes 15 minutes, and when the fertilised ova are washed, they are laid out in incubator trays with approximately 4,000 ova per tray. The incubator keeps oxygenated water flowing past the ova in a cascade effect, running from one tray to the next. Now it is a matter of waiting for nature to take over as the ova develops slowly in the cold winter water. It's now spring, and the river vegetation is starting to show new life again. In the hatchery, there's signs of life too. After 10 weeks, the ova start to show signs of development, best indicated by the eyes of the developing ulvin. Survival in the hatchery runs at 90%. Once hatched, the emerging juvenile salmon or ulvin have a protruding yolk sac, which sustains them through the incubation process. Once this is used up, the emerging small fry must feed. When the fry are approximately 14 weeks old, they are ready to be stalked out into the wild. Staff gently net some of the fry from the rearing tanks and place them in highly oxygenated bags of water. These fry are taken to the upper reaches of the river bush, which contains suitable nursery habitat, while the rest will stay on the farm. This will be their home for the next 1 to 2 years. Before releasing the fry into the stream, the fish are acclimatised to the watercourse, and are then placed sparsely throughout the stream to ensure the fry have the best chances for survival and develop into healthy salmon parr. It takes 1 to 2 years before the salmon parr lose their distinctive markings and turn silver as their bodies prepare for a life at sea. Just before the smolting process, when the salmon parr are preparing to go to sea, fish on the farm have their adipose fin trimmed to identify that they are hatchery fish. A small serial number micro tag made from wire is inserted by a tagging machine into the smolt's nose. This will be used to identify the fish if it returns from the sea as an adult salmon. These tags will be removed from the tissue samples extracted from the nose of the returning hatchery adult salmon to check the serial numbers and link with the statistics taken in the adult trap. A very sensitive metal detector is used to identify the location of the tiny tag, and a powerful microscope is needed to see the serial code. The trapping of the wild smolt allows the numbers of these wild juvenile salmon going to sea to be calculated. It also determines the quality of the immigrating salmon. At this stage, the smolts are delicate as their bodies are going through a major physiological change as they prepare to enter a marine environment. They must be handled as little as possible and with great care. The smolts are now preparing for the long, arduous and dangerous migration to their feeding grounds in the Atlantic. To study survival and behaviour, some smolts are tagged with acoustic transmitters. The smolt is anaesthetised first and the tag is inserted into the body cavity. After the internal tag has been inserted, the fish is allowed to recover before it is released with a batch of other smolts. These tags transmit an acoustic signal which can be tracked by an operator with a mobile antenna, or they may be detected on stationary receivers out at sea. The data shows when and how many smolts have successfully made it to the ocean. But danger is waiting from mammals, freshwater and marine fish, and a host of birds, including herons, gannets, seagulls, and cormorants. Now the struggle for survival at sea begins, until the survivors return in over a year's time. The long-term data from the Bushmills monitoring programme allows scientists to assess the status and health of local salmon stocks. It provides the basis for salmon management in Northern Ireland, helps assess the effectiveness of local enhancement measures, and contributes to the international salmon research and conservation efforts. The Bushmills work has helped identify many of the emerging pressures and threats facing salmon stocks, such as reduced marine survival and poor growth at sea. Against a background of climate change and human-induced pressures on our rivers and oceans, the Bushmill Salmon Station is actively collaborating with partners across the North Atlantic to understand the reasons for the decline in our salmon stocks and to identify new ways to conserve and enhance this iconic species.